In this video, we're going to go over naming and writing formulas for molecular or covalent compounds. So we're going to look at binary covalent compounds, which are covalent compounds composed of two different elements. And those different elements have to be non-metals. Covalent compounds can also be called molecular compounds. So here we have a formula for a molecular compound. We have two nonmetals, nitrogen and oxygen. They have subscripts as well, two nitrogens and one oxygen, but you don't have to put the one. Unlike ionic compounds, molecular compounds can actually exist as little molecules. So for example, H2O, which is molecular, can actually exist as a water molecule like this, as opposed to having to exist in a crystal. So we're going to start with naming, and then we'll go with formula writing. So molecular compounds, remember that they are compounds that are made up of two or more non-metals, and they're held together by a covalent bond, which is a sharing of electrons. When you're naming these type of compounds, you want to name the first element first, the one on the left. And then, so in this case, if you want to name N2O, the first element is nitrogen. The second element, you have to name it and change its ending to IDE, so nitrogen oxide. But what's different here is that you need to use these prefixes, words that go in the front, prefix, Greek prefix, to identify how many of each element you have. So we have two nitrogens, so it's dinitrogen. And then we have one oxygen, that's mono. So dinitrogen monoxide would be the name for this compound here. You wouldn't put monoxide because you have two O's following each other, so you could get rid of the one O there. But again, we have to use the Greek prefixes when we're dealing with molecular compounds. We would not do this for ionic. Okay, so for example, if I had Na2O, this is sodium oxide. Ionic does not use the Greek prefixes, but covalent or molecular does. So we'll try this example here. Here we have, so our first element is phosphorus, and there's two of them. So we have diphosphorus, and then oxide. So we have diphosphorus pentoxide, because there's five. The reason I didn't put pentaoxide is because there were two vowels following each other, O and the A. So I took off the A from the penta. So pentoxide instead of pentaoxide. Let's do another example. Here we have PbRO3. So in this case, you have to pay attention. If the first element is a 1, you don't put mono. If the second element was 1, you would put it. So here we're not putting monophosphorus, we're just putting phosphorus. Tribromide. Because there's 3 there. 3. Tribromide. Again, no mono here because it's the first element. That's 1. So for example, let's do another example. CO. This is carbon. I don't put mono for the carbon because it's the first element is 1. But for the second one, I can put monoxide. Or CO2. Carbon, I don't put monocarbon, I just put carbon. And then dioxide. Now, you could also make a formula from a name. Making the formulas for molecular compounds is pretty straightforward. What you do is you basically just write the symbols side by side. So let's say we're dealing with disulfur decafluoride. The symbol for sulfur is S. The symbol for fluoride is F, and then we put the subscripts in. So subscripts. The prefix will indicate, for example here, di, that there's 2 sulfurs. And the deca indicates that there's 10. You need to remember this table of prefixes. Deca means 10. So now we're going to have S2, F10. Do not reduce for molecular compounds, because molecular compounds actually exist as individual molecules. You could reduce for ionic because it's the ratio, but these actually exist as individual molecules. In this individual molecule, there's 2 S's and 10 F's. Let's do another one. So carbon monoxide, no prefix in front of the carbon, that means 1. Monoxide, mono means 1. Carbon dioxide, no prefix in front of the carbon, means 1. Dioxide means 2. Let's do a few more examples here. Sulfur pentafluoride. Nothing in front of sulfur, so you can pause the video and try it yourself. Means 1. Pentafluoride, F5. Carbon tetrafluoride. So 1 carbon, because there's nothing in front of the carbon there. And tetra means 4. So notice there's no crisscrossing, there's no reducing. It's just writing down the formula based on the name. So you can pause the video and try these ones here yourself. You have to name the compound. So here we have sulfur hexafluoride. You should look up this video. People inhale sulfur hexafluoride, and it does the opposite of what helium does. It's really, really cool. So look up sulfur hexafluoride and take a look at what that does. Here we have dinitrogen pentoxide. Here we have phosphorus pentachloride. Here we have nitrogen trifluoride. As you all know, this is water, the common name. We usually go with that just because we use it so often. But if you want to name it based on the rules we learned, by the way, for all this naming, it's called IUPAC. Look up what that stands for. It's pretty neat. So this is dihydrogen monoxide. SO3, there's no charge, so this is SO3, the compound, not the polyatomic ion, right? If it was a polyatomic ion, it'd be SO3 2-. This is SO3, the compound. So this is sulfur, there's 1, trioxide. Here there's 2 vowels that follow each other, but when it's an I and another vowel, you can keep them together, so trioxide. Here we have sulfur dioxide. Here we have phosphorus, and then pentasulfide. And then here we have carbon disulfide. You should also be able to make formulas from the names, so you can pause the video, try it yourself, and then check out my answers. So phosphorus pentasulfide, PS5. Oh, PS5, no one get one of those yet? Carbon monoxide, CO. Nitrogen triiodide, Ni3. Nitrogen dioxide, NO2. Diphosphorus trioxide, so there's 2 phosphorus and there's 3 O's. Carbon disulfide, CS2. Nitrogen monoxide, 1N, 1O. Phosphorus tribromide, 1P, 3 BRs.